Okay, question 21. So it says here ABCD is a quadrilateral. AB equals CD, and you can see these dashed lines there, which means they're same length. And angle ABC is the same as BCD. So these two are the same because they're the same length, and this is a horizontal line. So that means that these angles are going to be the same. So prove that AC, this line here, and BD are equal. So essentially what it wants to know is prove that the line BD, which should be straight, okay, prove that these two lines are equal. Right, so we know that AB and CD are equal. It's given to us. And we know that the angle ABC is equal to angle BCD, right? So BC is common to both triangle ABC and BCD. Okay, so what I mean by that is BC, right, is common to both ABC and BCD. So therefore triangle ABC and BCD are congruent. So then that means SAS, and therefore AC equals BD. And this just means that, if you remember from before, that SAS refers to side, angle, side. Okay, and where we have a side, angle, side, it means that you have two triangles where we know two sides and an equal angle. And as we mentioned before, this allows us to prove that AC equals BD. Okay, because we have this side here, this angle here, and this side here, and likewise we have this side here, this angle here, and this side here. Okay. Okay, question 22. So since the working out for this question is slightly longer than usual, I will do it on a different software. So question 22, it says the diagram shows a hexagon A, B, C, D, E, F, and you have it here. It shows that A, B, E, F and C, B, E, D are congruent parallelograms. So essentially A, B, E, F is the same as C, B, E, D in that they're congruent parallelograms. Where A, B and B, C, so A, B and C, B are equal to X, and point P is the point on AF, which is here, and Q is the point on CD, such that BP and BQ are equal to 10. Right, so equal to 10, equal to 10. Given that ABC, so we've got ABC, so that's there, 30. Probably should use a different color. Prove this. So we've got cos PBQ. Okay. So let's prove it. So let's draw our triangles. So we've got a triangle here. Let's call this ABC. We know that's going to be 30. We know this is X. This is X here. And then we have another triangle. which is P, B, and Q. And we know this is going to be P, B, and Q. We know that the lengths are 10 on BP and BQ because we're told that. And so we want to, first of all, first step that I'm going to do is, so step 1. So I'm going to find AC in terms of X. So I'm going to find this one here in terms of X. So I'm going to use, because we're talking about cosine here, I'm going to use the cosine rule for finding the lengths. So a squared equals b squared plus c squared minus 2bc cos a. And I'm going to have completing this and subbing in the relevant details. 2x squared. Now cos a, and in this case a is 30, equals the square root of 3 over 2. So I have the square root of 3 over 2. And we finish this off. It's collecting like terms. 2x squared. 2x squared. And now if we factorize 1 minus square root of 1 minus square root of 3 over 2, and then we know for a fact that AC equals PQ because AC there and PQ are the same because they're on the distance between the two are based on a parallelogram. Okay, so if we want to find PBQ, we can say cos A equals, and again we can use the formula, the cosine formula for finding the angle. So we get cos PBQ equals, remember we refer back to our triangle here, so we had the sides equal to 10. So 10 squared plus 10 squared minus, so now we have the a squared. So for the a squared we're going to use what we had here before. So 2x minus 2x squared square root of 3 over 2. Okay, and then this is going to be over 2bc, so 210 times 10. So this is going to equal, so this is 100, so that's 200. Keep the brackets as is. And then that's over 200. Now, what we can do is we separate, let's do this. So we essentially want something like this. So you've got over 200. So essentially what we can do is we can separate into two different fractions as follows. So we get this equals 1 minus 2x squared minus 2x squared square root of 3 over 2 over 200. Brilliant. So let's compare that to what we want here. And then the x squared is outside. So x squared goes outside, so 1 minus, and then we said 2x squared. Now the other thing is we can cancel these two here. Square root of 3. We're going to put the x squared outside over 200. And we can see that's exactly what we have. So cos PBQ equals 1 minus, and then this fraction here to the power next to x squared, and that's what we've got here. And that brings us to the end of the exam.